All right, guys, in this problem, what it's asking us to do is find all 5 parts and the opening direction of the parabola y minus 2 quantity squared equals 16 times the quantity x plus 3, and then graph it. All right, so our 5 parts are the vertex, the p-value, the focus, the axis of symmetry, AOS, and the directrix. All right, and then the direction of opening, whether it be up, down, left, or right. All right, so first off, here are y values are squares. We have to remember our kind of general form of this equation, which uses this: y minus k quantity squared equals 4p times the quantity x minus h. Okay, where hk is the vertex. Okay, p is going to be the distance from our vertex to our focus, and our vertex to our directrix, which we'll talk about here in a little bit. And I think once we know those things, we should have enough to get it. All right, we can get some of these other values along the way as we go. So right away, what I can see is hk from here, from my given equation is going to be -3, 2. Right, -3, 2. That's my vertex. So -3, 2, just like that, we get the vertex. I'm going to graph these as we go. -3, 1, 2, 3, and then 2. Be right here. That is the vertex. All right, the other part is when our y's are squared, the y values are squared, what we know is this is either going to open left or right. Okay, and specifically in this one, since we have a positive p-value means it's going to open to the right. Okay, if our x's were written first, those were squared, it was positive, then it opened up. But since our y's are squared, and this is positive, it's going to open to the right. Okay, the other thing I know is if I take 4p in the general part, but now mine equals 16, okay, if I solve for p here, p equals 4. P equals 4. So since it has to open to the right, what does this tell me? Well, this is the distance from my vertex to my focus. And the focus is on the inside of a parabola. If this is opening to the right, I'm going to go 1, 2, 3, 4. Right here, that's going to be my focus. Put a little V by this for vertex and F by this for focus. In the opposite direction, 4 spots from our vertex is going to be the directrix. All right, that's going to be 1, 2, 3, 4 this way. Okay, and that's a line. That's a line that's going to be perpendicular to the line that your vertex and your focus are on. Okay, so I plotted a lot of things here, and they actually are what some of these remaining parts are. We have the focus, which is that dot on the right, which is 1, 2, the point 1, 2. Okay, the dotted line is going to be our axis of symmetry. That's the line that both the focus and the vertex are on. In this case, this is the line y equals 2. Okay, then directrix is the vertical line, you see, and let's see, 1, 2, 3, 4, 5, 6, 7. This is back at x equals -7. So the vertical line x equals -7 is the directrix. And then earlier I said that this is opening to the right because our p-value is positive, and if the y's are the squared part, then it either opens left or right, positive, oh, it's going to the right. So we have right here. All right, so we got everything that we need, all 5 parts plus our opening direction. Now we can draw the curve of this. And as long as you start at your vertex, it opens the right way. Okay, I'm not too picky with how the curve looks. Obviously, this is definitely not perfect in that one. The idea is that it should be, any point on here should be the same distance from your directrix to your focus. Okay, but I'm not too picky with how you do this.